Acids, bases, and salts. Ionic compounds. The molecule of an ionic compound has two constituents, namely cation, that is positive ion or basic radical, and anion, that is negative ion or acidic radical. There is a force of attraction between these ions as they are oppositely charged, and that is called the ionic bond. The force of attraction between one positive charge on a cation and one negative charge on an anion makes one ionic bond. While studying static electricity, we have learned that there is a natural tendency of any body to change from an electrically charged state to an electrically neutral state. Why then is an electrically charged ion formed from a electrically balanced, that is neutral atom? The explanation lies in the electronic configuration of atoms. Let us see once again how the sodium and chlorine atoms form the Na plus and Cl minus, and as a result how the NaCl salt is formed. The figure here shows how this takes place. A sodium atom gives away one electron and a cation of sodium is formed. A chlorine atom takes up this one electron and forms an anion of chlorine, that is chloride ion. After the give and take of electrons is over, the electronic configuration of both the resulting ions has a complete octet. Due to the attraction between the unit but opposite charges on the two ions, an ionic bond is formed between Na plus and Cl minus, and the compound NaCl is formed. Let us understand how dissociation of ionic compounds, for example, salt, takes place in aqueous solution. On dissolving in water, an ionic compound forms an aqueous solution. In the solid state, the oppositely charged ions in the ionic compound are sitting side by side. When an ionic compound begins to dissolve in water, the water molecules push themselves in between the ions of the compound and separate them from each other. That is to say, an ionic compound dissociates while forming an aqueous solution. Each of the dissociated ions in the aqueous solution is surrounded by water molecules. This state is indicated by writing AQ, meaning aqueous, on the right of the symbol of the ion. Arrhenius theory of acids and bases. The Swedish scientist Arrhenius put forth a theory of acids and bases in the year 1887. This theory gives definitions of acids and bases as follows. Acid. An acid is a substance which on dissolving in water gives rise to H plus ion as the only cation. For example, hydrochloric acid, sulfuric acid, and carbonic acid. From the reaction below, we can see that acid undergoes dissociation to form H plus ion as the only cation and the concerned acidic radicals. Base. A base is a substance which on dissolving in water gives rise to the OH minus ion as the only anion, for example, sodium hydroxide and calcium hydroxide. From the reaction given below, we can see that a base undergoes dissociation to form OH minus ion as the only anion and the concerned basic radicals. Classification of acids and bases. Acids and bases are classified into strong and weak types on the basis of the extent to which they dissociate in their aqueous solutions. First, strong acid. On dissolving in water, a strong acid dissociates almost completely, and the resulting aqueous solution contains mainly H plus ions and the concerned acidic radical. For example, hydrochloric acid, hydrobromic acid, sulfuric acid, nitric acid. Next, weak acid. On dissolving in water, a weak acid does not dissociate completely, and the resulting aqueous solution contains H plus ion and the concerned acidic radical in small proportion along with large proportion of the undissociated molecules of the acid. For example, carbonic acid and acetic acid. Strong base. On dissolving in water, a strong base dissociates almost completely, and the resulting aqueous solution contains mainly OH minus ions and the concerned basic radicals. For example, sodium hydroxide, potassium hydroxide, calcium hydroxide, and sodium oxide. Next, weak base. On dissolving in water, a weak base does not dissociate completely, and the resulting aqueous solution contains a small proportion of OH minus ions and the concerned basic radical, along with a large proportion of undissociated molecules of the base. For example, ammonium hydroxide. Let us see the definition of alkali. The bases which are highly soluble in water are called alkali. For example, sodium hydroxide, potassium hydroxide, ammonia. Here, sodium hydroxide and potassium hydroxide are strong alkalis, while ammonia is an example of a weak alkali. Thank you.